Okay, this video is to just show how you would be picking out a conjugate acid and a conjugate base, as well as the acid and base. So I typically like to look at my reactants. Sometimes this will be very obvious. In this case it is. Remember, by definition, an acid has to donate a proton, and a proton is a hydrogen ion, an H+. So CN does not have any hydrogen in it. This cannot be your acid. This is the only candidate in the reactants that can be the acid. So it is what donates a hydrogen. Now, the other way to look at it is if you suspect this is your acid and it's going to be donating the hydrogen ion, you want to look to the products and figure out if that's what it's done. So you're looking over here and figuring out, what does that H3O become? Now, it most resembles this, H2O. So H2O is the result when the acid, the H3O plus, gives away a hydrogen ion. You're left with the H2O. So I know this is my acid. That by default makes the CN the base. And remember, the other way to look at this is to figure out which of these two things has absorbed a proton, because a base by definition now is something that absorbs a proton or collects a proton. So if you look at these two things and then look to the product, notice that the CN minus has become HCN. It has absorbed a hydrogen ion, and the hydrogen atom is now part of its structure. So this is definitely your base. When you're looking for the conjugate of those two, you want to figure out what the H3O has become in the products, and that would be its conjugate base. And we've kind of already outlined that. This is the acid. That means it's giving away a hydrogen, and you're left with H2O. The H2O is your conjugate base. And that means the CN minus becomes the HCN. That means this is your conjugate acid.